Just now we dealt with the problem of vertical nails, but how about the horizontal nails? What are their difference? So in this problem we are going to explore this stuff. Two wood box beams A and B, they have the same outside dimensions, which are 200mm times 360mm. All the members of those beams has a thickness of 20mm. Both beams are formed by nailing, but for beam A, it is formed by the vertical nail. For beam B, it is formed by the horizontal nail. Each nail has an allowable shear load of 250 newtons, and the beams are designed for a shear force V equals to 3.2 kilonewtons. So this time, V max is given to be 3.2 kilonewtons. What is the maximum longitudinal spacing, SA, for the nails in A, and what is the maximum longitudinal spacing, SB, for the nails in beam B? And then you are going to comment which beam is more efficient in resisting the shear force. For the A part of this problem, it is very similar to the previous example because it is vertical nail. We need to evaluate the first moment of inertia for the region above the nailing boundary. First, evaluate the second moment of inertia, I. It is given by 3.4 times 10 to the power minus 4 meter to the power 4. And the first moment of inertia of the region above the nailing edge, here, after a series of computation, it is given by 6.8 times 10 to the power minus 4 meter to the power 3. Then we can compute the shear flow by substituting all those numbers into this equation. The shear flow is given by 6,387 Newton per meter. Since two nails located here are resisting the shear flow, and the force exerting on each nail is given by the shear flow times the spacing, then we can write 2 times the allowable force of nail equals to the shear flow times the maximum spacing. Then the maximum spacing is given by 2 times the allowable force of the nail divided by the shear flow, which is 78.3 millimeters. For part B, it is talking about a horizontal nail, but the computation of first moment of inertia would be different. So let's observe the difference of the region used to compute the first moment of inertia. We can see that the region used is like this. I don't know how to express it in words, but you can see the difference between A and B. So the first moment of inertia is given by 160 times 20 times 170, which is 5.4 times 10 to the power minus 4 meter cubed. The shear flow is given by this, by substituting all those known informations. Then the maximum spacing is given by 97.9 millimeters. By comparing those results, we can see that the maximum spacing for beam B is larger than that of A. A conclusion can be drawn that since beam B has a larger maximum spacing, it allows to reduce the density of the nails used on this beam, and consequently you don't need to use too many nails on a beam. Therefore, beam B is more efficient in resisting the shear force.